All right, the purpose of this tutorial is to find the coordinates going around the unit circle, knowing only degrees. So the first coordinates that are easy to find are the quadrant angles, meaning 0 degrees, 90, 180. So it's where the x and y axis lie, and it's the angles that are dividing up the quadrants. All right, so the unit circle is a length of 1, so simply enough, for 0 degrees, this would be 1, this would be 0. Now this is a good time to remind you that x is equal to the cosine of whatever angle, and y is equal to the sine of whatever angle. All right, so this would be saying that the cosine of 0 degrees is 1, and the sine of 0 degrees is 0. Right, so this would be 0, 1, negative 1, 0, and down at the bottom, you would have 0, negative 1. All right, 30 degrees and 60 degrees are part of the same triangle, meaning right, this is a 30, 60, 90 triangle here. Right, so the angle up here is 60 degrees, the angle here is 30, and this is originally where we found these relationships. So a 30, 60, 90 is half of an equilateral. Kind of like if I extended this, right, this triangle here would be an equilateral. Well, if this is length 1, this would have to be 1/2. And then using the Pythagorean theorem, we derive that this is root 3 over 2. All right, so the x value would be root 3 over 2. And the y value is 1/2. Thus saying the cosine of 30 degrees is the square root of 3 divided by 2, and the sine of 30 degrees is 1/2. Right, I'm going to erase that. All right, similarly, this is a 30, 60, 90, but the 60-degree angle is down at the bottom. All right, so the 30-degree angle is up here. All right, so the 1/2 would actually be at the bottom, so the x value for 60 degrees, that's 1/2, and the y would be derived to be root 3 over 2, meaning that the cosine of 60 degrees is 1/2, and the sine of 60 degrees is root 3 over 2. All right, 45-degree angle, 45, 45, 90 triangle is half of a square, meaning that this is a length 1. These two sides are the same length. And if we had that be x and x, right, x squared plus x squared is equal to 1 squared. So 2x squared is equal to 1. X squared is equal to 1/2. And if you square root that, we get that that is the square root of 2 over 2. And they're the same length. All right. Every other angle on the unit circle will be using these exact same values. Right? Because it's the same distances. The difference is direction. Right? And it's no different than when you've learned it in earlier grades that, well, the first quadrant is positive and positive. Normally we think that is x, y. Now we're going to be thinking of it as cosine and sine. So cosine and sine are both positive in the first quadrant. In the second quadrant, cosine is negative, but sine is positive. Right? In the third quadrant, both cosine and sine are negative. And in the fourth quadrant, we have that cosine is positive and sine is negative. All right, so if we look at 120 degrees, we can see that this is the same height, right? This would be referring to a 60-degree angle. So the reference angle for 120 degrees is called a reference angle because I'm referring to 60. Basically, a reference angle is the angle that lies in the first quadrant that you would refer to for any quadrant that does not lie in the first quadrant in order to know its coordinates. So for 120 degrees, it's going to be the same coordinates as 60 degrees, right? So I would have 1/2 and root 3 over 2. All right, so I got that same one, except for this would be negative 1/2. All right, 135 degrees would refer to 45. All right, another way to know the reference angle, it's the angle it makes with the x-axis. So this is a 45-degree angle here. All right, so those would both be root 2 over root 2. The difference is that cosine, or the x value, would in fact be negative. All right, and then for 150 degrees, again, this angle that it makes with the x-axis is 30 degrees. That's why its reference angle is 30 degrees, except for the angles are now different. So it would be, not the angles are different, the signs are different. So this would be negative root 3 over 2 and positive 1/2. Now, usually when people are filling in the unit circle, it's pretty easy to remember the quadrant angles. Occasionally, you might put 1, 0 up here on accident, or 0, 1, and vice versa for the other quadrants. Most people don't have trouble with 45 degrees because it's in the middle and the same, but occasionally 30 degrees and 60 degrees might get switched, or when we get to these reference angles, they're switched. The easiest way for me to remember it is, well, if I'm looking for 30 degrees, right, the length of x, this is clearly longer than y. So I know x would be the root 3 and y would be the 1. All right, same idea if I was thinking about this 60-degree angle. Right, this y is clearly longer than the x. So I know that that y would clearly be root 3 over 2. All right, so we'll go in and we'll fill in the rest. Go ahead and look at it. So it's color-coded also for the reference angles. All right, so if we get into the third and fourth quadrant, we can see that they're both negative in the third quadrant, and only sine is negative in the fourth quadrant. Also, it's important in it, so these are all the values that we know exact values of, and they're basically the angles we'll be working with for a good bit until we know how to, find the exact value of half that angle or double that angle or a sum of two angles. So there's a different way that calculators know how to estimate them, but these are the exact values we know. All right, so and that's because they come from those special right triangles. Right, the only other thing we would need to talk about is how to evaluate something that is greater than 360. So I think of something like, I don't know, let's just say 750 degrees. Well, that would be 2 full rotations, right? Let me get a color. Let's see. All right, so 750 would be, right, there's 360. Here's another 360, so that's 720. Then I'd have 30 left over. So it's coterminal with the terminal sides, that this side here, that ending side, it's coterminal with 30 degrees. So 750 degrees, right? If I took away 360 twice, it's the same thing as 30 degrees. All right. Same thing if I was going in the negative directions, let's say negative 1200. That's that piece. And we'll look at this more in detail in the next tutorial. But if I was going the negative direction, I'm going to go clockwise. So negative 1200, well, I'd have 360 degrees plus another 360, so that's going to get me to 720, plus a negative 360, that gets me to 1080, and then I'll still have 120 degrees left. All right, so it'll actually be the same thing as 240. Right, because that would be negative 120. So if I look at, using arithmetic, if I had negative 1200 degrees, well, adding 363 times wouldn't be enough, so it'd be really like 4 times 360. I mean, you could add 364 times, but it's easier to be adding the multiple, so it's really negative 1200 plus 1440, which comes out to 240 degrees. All right, so we'll look at how would I find the sine of negative 1200. Well, I'd first have to know, well, this is the angle that is coterminal, meaning it would share the same end side with negative 1200 degrees. And then a 240 degree angle, if you had the angle with the x-axis, so if we go back here, at the angle this forms with the x-axis, you can see because it's color coded in blue, well, this angle is 60 degrees. So its reference angle would be 60 degrees. And we know it's in quadrant 3. All right, well, sine n, so if I was looking at, the sine of negative 1200, well, it's going to be the same thing as the sine of 60 degrees, so that would be root 3 over 2, except for the fact that it's in quadrant 3, so it would be negative. All right, and then the cosine would be the same thing as 60 degrees, except for it's also negative, so it would be negative 1/2. All right, and the next tutorial we'll look at just evaluating. So evaluating if it's between 0 and 360, if it's greater than 360, if it's less than 0, basically finding the coterminal angle, the reference angle, knowing what quadrant it lies in order to evaluate it. All right, that'll be the end of this tutorial. Hope it was helpful.